Ionic bonding and the properties of ionic substances. Positive ions, or cations, are formed when electrons are lost from the outer energy level of a metal atom or hydrogen. Example, lithium Li. Electronic configuration 2,1. That outer electron is lost to give lithium a full inner shell of 2 electrons. There's the electron that was lost. I could show it in terms of subshells. Negative ions or anions are formed when electrons are gained to the outer energy level of a non-metallic atom. Here's fluorine, electronic configuration 2,7. An electron gained to give me the F- ion, the anion, electronic configuration 2,8. And again, I could show this as the outer p suborbital gaining that electron to become full. The number of electrons lost or gained is determined by the electronic configuration of the atom. And ions usually have filled outer energy levels, except for the transition metal ions. Here we see elements chosen from 6 different groups. Their electronic configurations, and you can see at first sight we're looking at elements taken from the 3rd period. 3 occupied shells. Number of electrons lost or gained corresponds to the original number of outer electrons. Group 1, 1 in the outside shell, loses 1. Element from group 2 loses 2. Element from group 13 loses 3. And the charge on the ion formed corresponds to the number of negative electrons that were lost. Electronic configuration of the ion, that is, 2,8. Group 15, 16, 17, I see the outer number of electrons, and that dictates how many electrons are gained. Enough to give a full, stable, outer octet of electrons as shown. Charge on the ion corresponding to the number of electrons gained. If I stay with phosphorus for a minute, at first sight you might think phosphorus atoms could gain 3 electrons to acquire an electronic configuration of 2,8,8. They could lose 5. But the rule is, in terms of the number of electrons lost or gained, everything always goes the easiest way to obtain a full outer shell of electrons. An ionic bond is the electrostatic attraction between ions of opposite charge. I'll end with a couple of questions based on past paper questions, and you'll see it's important to understand that definition. Ionic compounds are formed when electrons are transferred from a metal atom to a non-metal atom. Now, that's just making ions. In parenthesis, it's not the definition of an ionic bond. Again, an ionic bond is the electrostatic attraction between oppositely charged ions. Under normal conditions, ionic compounds are solids with giant lattice structures. Ionic bonds do not exist in isolation. Each positive ion is attracted and surrounded by negative ions, and vice versa, e.g. sodium chloride. In sodium chloride, the grey positive sodium ions would be surrounded by 6 negatively charged chloride ions. Let's look at the grey ion in the very middle. That's representing sodium ion, Na+, and I can see negative ions to the left and the right, above and below. There would also be 2 in front and behind. This results in so many attractive forces holding the ions close together in the lattice, and the lattice just means a regular arrangement, and giving all ionic solids high melting and boiling points, lots of attractive forces, and we can see why ionic bonds do not exist in isolation. Each ion is attracted by oppositely charged ions around it. Of course, my structure is three-dimensional. Physical properties of ionic compounds. I've got three here: volatility, electrical conductivity, solubility. These are due to their structure. I've picked these three out. There are more, because this is what the IB focuses on. A volatile substance is one that evaporates or boils easily. Ionic substances have low volatility because of the large forces of attraction between ions. As we said already, under normal conditions, ionic substances are solid. If a crystal is struck, a whole layer of ions may slide over. Now we have ions with the same charge next to each other. Let me go back a little. There's my diagram. Imagine that the lattice structure was struck on the far right. My ions would slide down one level. When they did, I'm going to have ions of the same charge next to each other. That will cause repulsion, and so the crystal breaks. That means that ionic substances are brittle. When they're heated strongly, it's got to be strongly, they will melt, and the liquid they form will conduct electricity because the ions are free to move. This is also the case, they'll also conduct electricity when an ionic substance dissolves in water. The ions are again free to move, and so the solution conducts. Also, because water is a polar solvent, ionic substances tend to be soluble in water. Each ion becomes surrounded by polar water molecules, and so attractive forces are established. Small point, but when ionic substances are insoluble, it's usually because the forces of attraction between the ions is large. So, if the ions have a high charge, or if they are smaller, the substance is less soluble. Two quick questions. Which best describes the process when magnesium reacts with chlorine? Let me put the periodic table up for a moment, or my version of it. The process when magnesium reacts with chlorine. If you haven't found them yet, magnesium is here in group 2, chlorine here in group 17. Back to the question. Magnesium atoms being in group 2 lose 2 electrons. A and B are right so far. Chlorine atoms, group 17, 7 in the outside energy level, only 1 is gained, making B the right answer. And which best describes ionic bonding? I'm saying it again, these questions are based on past paper questions I've encountered over the last 25 years or so. Correct answer, the electrostatic attraction between oppositely charged ions. That's it. If you found that at all useful, please hit like and subscribe. That just helps me.